Good morning, children. Children, I welcome you all to this session of physics, and we are on to the chapter pressure, force and pressure. And we have seen what force is all about. It is the push or pull, and now we're on to the pressure. We have seen pressure is force upon area. Now, dependence of pressure on the depth of a liquid. And children, you will be very surprised to know that the pressure in exerted by a liquid increases with increasing depth inside the liquid, right? If this depth is more, the pressure will be more, right? So let us move ahead. See, children, this is a very beautiful explanation of that. See that to show that the pressure of a liquid increases with the depth, you can see, take any vessel like this and make some holes, fill it with water, and you will find that the water coming out from the bottommost hole, see this one, will be the maximum, and the top one, the flow will be very low. You can see this flow here, that is very low from A, and you can see the flow from D is so swift and so fast because D is at the maximum depth, right, and A is at the minimum depth from the top, right. See, children, what I mean is from here to here, this depth is very low as in comparison to from here to here, right. Okay. In general, we can say that the pressure of a liquid increases with depth. In other words, the greater the depth of a point of liquid, the greater will be the pressure, right? And this thing I've already discussed with you. Now let us go to the another experiment. Aim demonstrate that a liquid exerts pressure on the wall of the container. And for that, see, this is the kind of the apparatus we have taken, right? And we are filling. Firstly, we take a plastic bottle and we're having a glass tube in it, and then a thin rubber sheet is put it out, and then we add some water to it, right. Take a plastic bottle like water bottle, fix a small glass tube and a little above the bottom of the plastic tube. We can do this by heating one end of the glass tube. See, we are onto this part here, and right, we are heating one under the glass tube slightly over a burner, and then inserting this hot end quickly into the wall of the plastic bottle. See this end here, this we have to heat and then insert inside the plastic bottle, right. And now take a thin sheet of rubber and put it on the other hand. Now see what we have to now fill half the plastic bottle with water. We will observe that the rubber sheet tied at the mouth of glass tube, it bulges out. See, there is a small bulge here, but if we increase the water level, you can well see that this bulge is more in comparison to this one, because in this case, in the C case, there the pressure is more than B, right. So we can infer from this is a liquid exerts pressure on the wall of its container, and the pressure exerted by liquid on the wall of its container increases with the increasing depth. Now we come to the super most important part of this chapter, which is Pascal's law. Pascal was a French scientist. Blaise Pascal observed that pressure in a fluid rests is thus all same in all the points if they are at the same height. According to Pascal's law, any force applied to a confined fluid is transmitted uniformly in all directions throughout the fluid, regardless of the shape of the container, right. So the Pascal law is that any force applied on a confined fluid transmitted uniformly throughout, regardless of its shape of the container, right. This principle of Pascal's law is used in various mechanical devices, and one is very important one is hydraulic lift, right. It is a simple construction in which two drums of different areas are used to lift objects. See, um, area and force is a smaller base go up, right? This is an experiment. Many a times this is due to the very high pressure exerted by water on the sides of the pipe, so that such a fountain of water is formed. So the formation of fountain of water from leaking pipes of water supply pipeline tells us that water exerts pressure on the wall of the container, right? So let us on the bottom of the container, right? A transparent plastic pipe and the thin rubber sheet, right? And we stretch the thin rubber sheet and tie it tightly over the end of the plastic and keep the pipe vertical. Let us pour some water. We will find that the rubber sheet is stretched and bulges out. Then we add more water, then it bulges out further, and in the C part, see it's half, almost half, more than half is filled with the water, and see the bulge, right? That a liquid exerts pressure on the bottom of its container, and the pressure exerted by liquid depends on height of the liquid column. That a liquid exerts downward pressure on the base of its container. Though it may seem awkward, but a liquid exerts pressure in the upward direction also. So in general, we can say a liquid exerts pressure in all the directions. Right? Now we come to the pressure exerted by gases. The substances such as hydrogen, helium, oxygen, nitrogen, carbon dioxide, etc. are gases, and all the gases exert pressure on the walls of their container. Though pressure is exerted by all the gases, but since air is the most common gas, therefore we will discuss the pressure exerted by air in detail. Air exerts pressure in all directions. Like children, see, this is something very interesting, that air also exerts pressure, and that it exerts in all the direction, right? Now, how it does so? Air is a mixture of gases. All the gases are made up of tiny particles called molecules, which move around quickly in all directions. And this movement is called the Brownian motion. The fast-moving gas molecules collide with one another and with the walls of the container in which they are kept. When the fast-moving gas molecules collide with the walls of their container, they exert a force on the wall of the container. This force produces gas pressure. We can now say that air pressure arises due to the constant collisions of the tiny molecules of gases present there, right? Okay, now see, the example is of a rubber balloon, right? We blow more air and the rubber balloon inflates, right? See here, the two examples are given. When air is filled into the balloon, I am here, children. When the air is filled into a balloon with our mouth, the balloon gas gets inflated, bigger inside. Into bicycle tube with a pump, the tube gets inflated, right? Now we will now describe another type of air pressure called the atmospheric pressure, which is due to the weight of the air present in the atmosphere. Now atmospheric pressure, we live in the earth and there is a lot of air above us. The layer of air above the earth is called atmosphere. The air in our atmosphere exerts up to 300 kilometers above the surface of earth. The atmosphere contains a tremendous amount of air. Air has weight, so the atmosphere consisting of tremendous amount of air has enormous weight. The weight of the atmosphere exerts a pressure on the surface of the earth and on all the objects of the earth, including ourselves. This pressure is called atmospheric pressure. So we can say atmospheric pressure is the pressure, the air pressure which is exerted by the weight of the air on present on the atmosphere. Right? Atmospheric pressure is the air pressure which is exerted by the weight of the earth present in the atmosphere, right? So that is the atmosphere. The atmospheric pressure on the surface of the earth is 101.3 kilopascal. Please remember this is the normal atmospheric pressure, 101.3 kilopascals, which is equivalent to the weight of elephants pressing on each square meter area, right? Therefore this magnitude of air is very heavy, right? Now the magnitude of atmospheric pressure, right? So we have seen this. We know that the pressure is force per unit area. Now if we imagine a unit area of earth's surface and a very tall column filled with air standing on it, then the weight of the air in this column will be atmospheric pressure, right? So the SI unit of area is Pascal, a square meter. Therefore we can also say atmospheric pressure is equal to the weight of the air present in a very tall column of air standing 1 square meter area of the earth, right? So with that we come to the end of the chapter, right? I hope you enjoyed it as much as I did in making it, and until we meet again, it's a goodbye.